Right, hi everyone. Today I'm going to demonstrate how to use the software SAP2000 to design this plain reinforced concrete frame. So before we look at SAP2000, let's see what exactly we mean by designing this concrete frame. Right, so let's look at this picture here. So we have a reinforced concrete beam here showing all the details. So on the top you can see there are a number of steel reinforcement depending on the hooking moment, and then at the bottom there are another set of bottom reinforcement depending on the sacking moment magnitude. And then along the beam you can also see these rectangular loops which are called shear links, and they are separated from each other by a certain distance. This distance is called the shearing spacing. So what SAP2000 is going to do for you is, depending on, after the analysis, the bending moment distribution and also the shear force distribution, they are going to calculate the amount of top reinforcement in terms of area and the amount of bottom reinforcement in terms of the area of steel, and also the shear length along the beam at different points along the beam. And that's what SAP2000 is going to calculate for you. And then similarly for columns along the height, the SAP2000 will calculate the amount of vertical reinforcement, and also these these rectangular loops, which are usually called column ties, along the height of the column, depending on the axial force, bending moment, and shear force along the column from the analysis. So that's exactly what we mean by designing this frame using SAP2000. The software would calculate all these top and bottom bars, shear lengths, column ties, vertical bars, all these areas. And then the next thing is to look at the concrete code that we're going to use. It's the 2013 version, the Hong Kong code. The cover looks something like this. There are a number of parameters that we're going to use. The first one would be the concrete material properties, and that is the concrete grade C40. That's what we're going to assume for our example. The corresponding strength, of course, is 40 Newton per millimeter square. The Young's modulus grade 40, that would be 25.1. Another one would be the concrete cover, depending on the exposure condition, which we're going to assume as 1 in our example, or classified as mild. So for mild condition exposure and concrete grade 40, the corresponding concrete cover that we need is 30 millimeters. And then what about the rebar reinforcement? So let's look at the reinforcement. For reinforcement, there are two types: the grade 250, which is the mild steel, and the grade 500, which is the high strength reinforcement. That's the corresponding U strength. Okay, 250 for mild, 500 for high strength. The Young's modulus is also given in the code, the corresponding density of rebar. Okay, and then the last thing we need from the concrete code is the load combination factors, which is given on page 25. And you can see there are basically 3 different types of load combination. The first one is dead load plus live load. The second one is dead load plus wind load. And then the third one is dead load plus live load plus wind load. And those are the corresponding load factors. For example, if you're talking about dead plus live plus wind, then the dead load factor would be either 1.2 or 1.0. live load factor would be 1.2 or 0, and then the wind load factor would be 1.2. So we're going to make use of these factors to form the load combinations. And then now we are ready to look at SAP2000. Right, so first of all, in front of you, you can see, if you still remember these, this is actually the frame that we analyzed in part 1 of the video. Right, on the left, this is the wind load case. On the right, that's the live load case. The self-weight of the frame, of course, is calculated automatically by the computer program. So if you look at the material that we defined last time, double check that the concrete density 24.5 kilonewton per meter cube, and then the Young's modulus, according to the code of practice, it should be 225.1 kilonewton per millimeter square. Here we change it to kilonewton per meter square. Right, and then the most important number here is the concrete compressive strength, which is 40 Newton per millimeter square. So change it to kilonewton per meter square. That's 40,000. Okay, so let's just double check. Right. And then we're going to add the high strength reinforcement user. In the region, you just choose user, and the material type, make sure you choose rebar. And then let's start with the mild. The Young's modulus should be 77, and Young's modulus is just 2.0. And then the U stress, the U strength, or that's the most important number, and that should be 250 Newton per millimeter square, and you need to convert to kilonewton per meter square, so that would be 250,000. Okay, so that's done. Another one would be the the high strength steel. So that's high strength. Right, again you change this to 77. You change this one to 2.0. And then for high strength, that's 500 Newton per millimeter square. Again, when you convert to kilonewton per meter square, that becomes 500,000. Okay, right, so let's just double check the numbers. Okay, right, and then the material properties are defined. So let's look at the frame sections that we entered last time for beam A. Right, so look at the concrete reinforcement. Beam A is going to be designed as a beam. The longitudinal bars, that means the top or bottom reinforcement, we're going to choose high strength. Confinement bars, that means the lengths are mild. Concrete cover would be 30 millimeters, so it should be 0.03. Right, okay, and then that should be okay. So do the same thing for beam B. Concrete reinforcement, the longitudinal bars, high strength. Confinement, it's mild. concrete cover is 30 millimeters. Done. Column A, concrete reinforcement, longitudinal bars, we're gonna use high strength. The column ties, you see the word ties here, so that would be mild. The confine, the clear cover, it's for concrete cover, that's 30 millimeters. Okay, so that should be it. And at the bottom, make sure that you click this. Reinforcement is to be designed by the program. Okay, so that's done. And then what about column B? You do the same thing for concrete reinforcement. Change the longitudinal bars, that's the vertical bars, to high strength, and then the ties to mild, and then the the column B actually is a circular bar, so the tie should be circular. Cover still assumed to be 30. Okay, the reinforcement is to be designed. Okay, so done. Right, what about the next thing would be the load combinations. So last time we only defined two combinations, so let's say we're gonna define a few more this time, like what I showed you previously about the 3 basic combinations. So I'm going to modify, let's say, look at what I have for the first one, 1.4 and 1.6. okay, that's fine. And what about combination 2? That should be the dead and win. Okay, so that's fine. Right, so let me just add one more combination 3, which is the dead load 1.2 plus the live load 1.2 and also the wind load 1.2. okay, right. Because of time, I don't want to make this video too long, so I'm not going to input the other combinations, but in your in-class exercises you should try to follow these load factors and form all the necessary combinations. So I suspect there would be around 6 to 8 more combinations for you to input. But for me, just to save time, I just input 3 combinations. But then I'm going to input another one, okay, I'm going to add another combination, which I call it combination 4. This time, this is not trying to add the dead or live or win. What this combination 4 is trying to do is I'm trying to extract the minimum or maximum bending moment or shear force or axial force along the column or along the beam. Okay, so that's what I'm trying to do for this combination 4. I'm not trying to add dead or live or win. I'm trying to extract the maximum and the minimum from those combination 1, 2, and 3. So what I'm going to do is to change this load combination type to something called envelope, and then so here I'm going to put combination 1, combination 2, and combination 3. So make sure the scale factor is 1 here. So what this actually means is I'm trying to extract maximum and minimum values of bending moment and shear force from these from these three combinations, and that would be the result of my combination 4. Right, so that's okay. Right, so you got 4 combinations. Then I am going to, so now the frame section, everything is defined, right? The material, the rebar, the concrete section, the low combination, basically all done. So I'm going to analyze it again. Right, this is the XZ plane, and then I'm going to run it again. Right, so on my left you can see this is the dead load deformed shape. Let's just look at the deformed shape for what about combination 3. Let's see whether it, right, so it makes sense. Right, so the I just displayed the deformed shape, so that finished the analysis part. So I'm gonna design it. So what I'm gonna do is to go to design, choose concrete frame design. The first thing you need to do is to choose the code of practice that you use to design. So you choose this view or revise preference. So here on the top design code, you see this design code here. So change it to Hong Kong code. Somewhere down here, you see Hong Kong code of practice 2013, right? So that's done. And then the second thing is select the design combos. So what combination are going to design this frame? So I'm going to design the beam or column based on the maximum or minimum bending moment, shear force or axial force along the column or along the beam. So that means I'm going to choose combination 4 and put that here. That's my design load combination. Okay, and here I try to unclick this, so the design basically will be based on my combination 4. So that's okay. Now I'm going to start design, and that's done, right? And what you're seeing here, these funny numbers are actually the amount of reinforcement or the top or bottom reinforcement in terms of area along the beam, along the column. So if you look at the graphics, it doesn't actually tell you much. So the best way to display the result is to show the table, just like what we did last time. So you go to display, you show tables, and what we are going to do this time is to output not the forces, is to output the concrete beam or column data, the output data. So let me just output, let's say for example, the beam data. Okay, and then in this low case, I'm just going to select combination 4, and then just press OK here. So what you're seeing here is on the first column, that's the frame number, and then we have the beam A and beam B. And then along beam A, that's the location along beam A. Bear in mind our beam A is 10 meters long, so every half a meter SAP2000 will calculate some number for you. And then same thing for beam B, which is also 10 meters long. And then you can see the COM4, which is the envelope combination. And then you can see based on the maximum or minimum bending moment and shear force, they calculate the top area. That's the top reinforcement area. and this one, that's the bottom reinforcement areas. Bear in mind the units are meter square, and then this V com, of course, that's V always represents shear link, and that's the shear link. Okay, meter square per meter. Okay, that's the amount of shear link per meter length of link spacing. And the last two columns, you can see, fortunately we don't have any error message or warning message, so the thing is basically done. And to do the last bit, we try to export the table like what we did last time to Excel. That will help you to input further formula in order to calculate the final size and number of reinforcement for top and bottom of the beam, and also the shear length. Okay, so with that, I will end this second part of my video, and you will be given an assignment to do in the classroom.